It's time for Myth of the Week.
Oh yeah, and David actually says he's been there, done that. I agree, David.
Oh yeah.
Yeah, we've had to
I
deal with
think
that
anybody's
too.
been doing it for a while has.
Yeah. All right, myth number 112. Oh, we're getting up there with the myths now. So this myth, true or false, ground fault circuit interrupting devices are required in the NEC to prevent electrical shock. The answer to that is 100% false. There's not very many things out there that can really prevent electrical shock, but the whole purpose of a GFCI device is to limit the duration of a shock event and actually try to prevent electrocution death.
That's right.
So there's not a lot that really comes in. Like, I'm not really going to try to steal James's thunder because he's probably expert on this one as far as it comes to shock and everything like that. And yeah, and David's answering in there. So we're electricians. We're not computer code people. But no, awesome. Thanks for joining, and we really appreciate you having us and checking out James's sweet graphics and everything. So like I say, this comes down to a lot of times people have this false sense of security when it comes to ground fault circuit interrupters and thinking that they're supposed to just do all this stuff. But when it comes to reality, if you don't have a lot of things right, then these GFCIs aren't really going to function right. I actually had one on my front porch that was just basically like a regular outlet. It was just regular, like the whole inside part fused shut, and so it didn't trip or anything. So good thing I was testing them weekly or monthly, like James does on the Stallcup ranch, and and I actually replaced it, and I did replace it with a WR device. I did replace it with the weather resistant because that could have been part of the problem, and I didn't have a damp location cover on it, so that was another thing that I had to kind of do because in that porch area of the front of my house, that's considered a damp location, not a wet location. So you only just need the little flip cover and stuff, but we got it all figured out, and it was pretty awesome. But what do you think about this one, James?
Well, I remember when you asked me about it, and I said, "Well, hell yeah, you're going to get shot."
Mm.
Then I wanted to know how people answered, And then I thought about it. I thought, well, let's just sort of take a look at a few things. And when you get into the National Electrical Code, there really isn't much on it. The only thing you're really going to get into is the definition, and it just tells you it's a device intended for the protection of personnel that functions de-energize the circuit or portion thereof when established period of time.
100% correct, David. I did comply with 406.40.
Yeah, and when you really want to get into looking at a GFCI device, you're going to look at your UL standard 943, and what it's going to tell you is that the ground fault circuit interrupter is going to trip when that ground fault current is at 6 milliamps or higher. Okay, right. That is to clear it quickly. So you're still going to get shocked, but it's like you said, it's clearing it so you don't get electrocuted.
True.
Okay. Now, as I thought about that,
does all electrocution result in death? Or does some electrocution, can you survive? Is there survivable electrocution?
Well, yeah, everything can be survivable. Just a lot of it depends how long you're on it.
Because basically people say that if you're electrocuted, you died. If you got shocked, then you survived. So that's kind of interesting to look at, So.
Well, let me show you something here because I pulled some facts out on this. Okay. And I'm going to show you. This is going to be from the 70 document, okay? And I'm going to get over and I'm going to look at the annex here in a little bit, all right? And we're going to show you
I'm gonna have to agree with David on that one. If you're electrocuted, you died. That's what I thought. I didn't think you got electrocuted and you lived. I thought you got shocked and you lived.
I've actually somebody's been electrocuted and they survived, but they were screwed up really, really bad.
Okay.
And
so that would be the electrocution that caused their injury.
Yeah, I would say more than likely you're going to die, but there is a possibility that you could survive it. And but if you do, you're going to be messed up. And what really, when it comes to a shock, what really affects you the most is how long you're on the circuit.
True.
If you're on that is the defining moment. And more people. I'll show you here in a minute, but we're going to look at the BLM or BLS, the Bureau of Labor Statistics. Okay. And we keep these in the 70 document, and we go through this and go through some explanation of what the shock does. Okay. So let's look at this real quick. Now, in the general requirements of 70E, you're going to look at 110.10. All right. And they got general requirements here. And it tells you that employees shall be provided with GFCI protection where required by applicable state, federal, or local codes and standards. Okay. And then there's listed cord sets or devices incorporating listed GFCI protection for personnel identified for portable use shall be permitted. Now, that's going to be interesting because I'm going to show you some stuff here in a little bit on that and how these cord sets work. Okay.
Okay.
Now, when you get into the maintenance and construction of the GFCI protection, it says it shall be provided when an employee is operating or using cord sets, extension cords, of course, or cord and plug connected tools related to maintenance and construction activity. And then it goes into your different circuits and stuff. And it says where employees operate or use equipment by greater than 125 volt, 15, 20, or 30 amp circuits, they tell you GFCI protection or an assured equipment grounding program shall be implemented. Now, I'm going to tell you, if you want to go and use the assured equipment grounding conductor program, there's a lot of documentation you got to keep up with.
True.
All right. I would not do that.
So, a question for you.
Mm-hmm.
Would you need GFCI protection if you were plugging in a charger for a scissor lift?
You indoors?
Yep.
Nope. I don't think you do.
And David has a good one too, He says it seems that people misuse the term electrocuted, and he looks forward to your explanation. And yeah, I could see that, David. I think it goes to basically down to the fact of what King James is saying about the amount of duration that you're held up on that circuit, because that ground fault circuit interrupter would actually limit that length that you're exposed to that shock, and so it would be less severe, and I don't think you would call it electrocution at that point.
I'll give you an example. We did a case. It was a utility, and anyway, the guy, it came down. They were pulling cable, and the cable bounced and it went up. And anyway, it come down. He had tightened the rope, which he shouldn't have done, and it gave tension and it popped. Well, it came down through the line where he's holding it, and it come in, hit him, blew out his foot. I mean, literally took his foot off. And they naturally got him to the hospital and stuff, and he lived for 5 years, but he was messed up bad. It was inside and all that, and they worked on it, but it just didn't kill him right away. So that's what I'm saying. That it depends a lot on the amperage and what the internal your body receives and how far it exits and how long the duration is. His duration was probably nothing. He was on the ground, he was out, and they took him and they worked on him and everything. But if they hadn't worked on him, of course, he'd have died. Okay.
Yeah, and I mean, ultimately, his death was by electrocution.
Sure, it was.
Ultimately.
Well, ultimately, it was, and that's what I'm saying. You know, you're going to be messed up pretty bad from an electrocution, but you just don't automatically say it kills you right away, like a lot of people say. That's not exactly true.
I agree.
So, and then you got C, which is outdoors, tells you got to have GFCI protection. Then it talks about the testing here that it's got to be done in accordance with the manufacturer's instructions. Now, that is the basic requirements of what you're going to get out of 70E and 110.10.
Nice. I like
now, when you get over to Annex K, there's going to be another slide on this one. But what this gets into is talking about the electrical injuries. Okay? And they tell you that electrical injuries represent a serious workplace health and safety issue to electrical and non-electrical workers. And then this is data from the U.S. Bureau of Labor Statistics. That's the BLS I was talking about. Mm-hmm. And they indicate that there were nearly 6,000 fatal electrical injuries to workers in the United States from 1992 to 2012. And then the BLS stats also indicated that there were 24,100 non-fatal electrical injuries from 2003 to 2012. So these are all things that everybody can look here and get an idea of the injuries that happen. Now, the reason that we have this in showing this is because we started going in and the 70 document, instead of just dealing with basically putting in what you would see in OSHA 1910-302 through 308, we basically started dealing with shock protection and dealing with arc flash, and dealing with thermal burns and things like that. And ever since we started doing that, what it had showed here is that the injuries started to reduce.
Right.
Okay, that's what they're getting into here when you look at K1.
So is that Annex K?
Yeah, Annex K. Annex
okay.
K.
Okay.
And,
gotcha.
So, as I was saying, there are two general categories that pertain to electrical injury, and that's electrical shock and electrical burns. Okay? Now, I will tell you this. Most electrical shocks don't even get reported.
Sure.
Okay? It's got to be something that was an electrical injury before it's going to be reported, where the the Bureau of Labor Statistics have statistics on this. All right?
Right.
Now, as you go down and look at the last paragraph, they tell you here, about 98% of total occupational electrical injuries are electrical shock injuries. Okay? So they had a corporate case study examine electrical injury reporting and safety practices, found that 40% of electrical incidents involved 250 volt or less and were indicative of a misperception of electrical safety as a high voltage issue. Okay, so they're telling you these lower voltages that you're working with, these are where people are really getting hurt a lot. So a lot of times it's a misconception here. All right. And then it says, in addition, electrical incidents once again were found to involve a large share of non-electrical workers, with approximately 1/2 of incidents involving workers from outside electrical crafts. And then it says, research of electrical fatalities in constructions found that the highest proportion of fatalities, excuse me here, occurred in establishment with 10 or fewer employees, and pointed out that smaller employees could have fewer formal training requirements and less structured training in safety practices.
Right.
So that's why you've seen a shift in the smaller facilities that they're hiring out and having people come in and maintain their equipment and everything.
Hey, quick question for you.
Yeah.
Is there a definition of electrocution or electrical shock in 70E?
I think, if I'm not mistaken, I think there is for shock. Matter of fact, I will look that up here in just a second, and I'll
Okay.
pull it up on the
I'm
screen.
trying to just get David
Oh,
a good answer.
yeah, I've got. I don't think there's anything that deals with um, uh, electrocution. I don't
Gotcha.
think it does.
I think they just added electrical shock uh,
Well,
to
I
the last
know
70E.
they have electrical hazard that's in there. I am familiar. I remember that.
Right.
I was trying to remember. I know there's. I don't think it.
Oh, you got Quick McGraw draw here. He's Quick Draw McGraw's freaking already going over the link to check it out. But
I think
that'd be
when
awesome
you
if
go
there's
over
a
there, I'll go over
definition.
there in a minute. But I think there's not electrical shock. I think what it talks about is shock hazard. I,
Gotcha.
I think when you go over there, it sort of talks about your different power source frequencies and stuff, and the informational node and the path, and it'll talk about the path. But the thing, like I was talking about, it'll say in the duration time occurred through the body, and that's what I was talking about. And
Right.
uh, and that gets into your muscular contractions and your inability to let it go. Okay, and then of course that, depending on how long you're on it, that determines your tissue burn and stuff, and if it takes and causes ventricular fibrillation, which in turn, if you're on it too long, that results in what? Death.
Yeah,
Okay.
and just to kind of dumb down what James just said, because that's freaking really good explanation, is what happens is you have this electrical current that's on a frequency, and that frequency is it confuses your brain, it confuses your body, and basically it makes you have abnormal heartbeats, and basically it causes heart attack. But
Sure.
that's a really good explanation, James.
Yeah, and I think it's under. I think it's a definition of shock hazard. I don't think there's anything in there that says electric shock or anything like that. We if God, I'm going off memory here, but I think
Yeah.
it's under the definition of shock hazard. David's about to look. He can let me know I'm
Yeah.
100% correct.
David's gonna quick draw McGraw you and get it thrown down. But the whole thing is too that you have to understand is that I think it just got added to one of the standards, or I can't remember. I remember somebody talking about that it said shock, but it didn't say electrical shock.
Yeah.
So I think they added electrical shock to it.
But just to give you an example here, they tell you over 40% of all electrical fatalities in the U.S. involved overhead power line contact. And that's what I was giving the example a while ago, because I
What
was
up,
aware of
Burn
that.
Brothers? Welcome in the house, sir. Right
And
on, brother. Appreciate you.
then it says this includes overhead power line fatalities from direct contact by a worker, contact through hand carried objects, and contact through machines and vehicles. Okay.
Right.
And it like we have in the OSHA, our OSHA high voltage and telecommunications regulation book that we actually show where you have one of the lifts had made contact, and then we explain in there, do not get out of the truck, because we go out to a distance on different type of voltage levels out there, that if you get out or if you walk up that truck within that area, you could be shocked at that point. And
Yeah, and electrocuted. But big shout out to Mike Barr for teaching us all the utility side stuff. That was a lot of fun having Mike Barr on. We're going to have to have him on again.
yeah, we're going to be updating that subpart R and subpart V, and Mike's going to be working with us on that. And
oh yeah,
we will have
good
him coming
comment.
in.
100% correct.
Touch and step potential. That's right.
Yes, sir.
Now, this is the, for example here, this to give you an idea. It says from 2003 to 2009, there were 20,033 electrical injuries, of which only 1,573 were fatalities. Okay? So it said one worker died for every 12.74 electrical injuries. For that same period, there were 1,718,219 fall injuries, of which 5,279 were fatalities. One worker died for every 325 injuries. So as we do a little more look at this, it says
done.
I'm ready for you. It says of those 1,573 were electrical fatalities. And then we tell you a more detailed look at the demographics for 168 electrical fatalities in 2009 showed that 99% of deaths were the result of electrocution. See,
right.
And that's why I'm telling you, you're more than likely going to die, but you can't say it's always. They're telling you here there's 1% that can live through that.
Right.
So, you know, this gives a little statistics here so you can see what I'm saying about electrocution. You know, I've been involved in a case where somebody actually lived for 5 years longer, you know, but he was messed up. I mean, he was almost like a vegetable, really.
Right.
But this gives you some insight to that, and thoroughly it says what I just explained. Yeah, more than likely electrocution is going to kill you, but you just can't automatically say everybody dies from electrocution because it's not true. Okay? True. So that is my little